In this video, I will show you how Tevmo plugin collects energy model and calculates cooling loads for multi-story residential building consisting of individual models of architecture, structure and facades. This time we work with a skyscraper. The building consists of 3 different models, which are attached to the HVAC file as a link. Number of links doesn't affect the collection of the model. Let's use the plugin tool to create levels. Floor plans are automatically created along with the levels. Next, we add shared parameters that our plugin needs and select typical floors in our building, so as not to calculate all floors, but only bottom, top and some typical ones. This feature saves time on energy model collection and speeds up input of initial data in multi-story buildings. Then we create spaces by duplicating rooms from the architectural file. Spaces are created on all floors except typical ones. Next, we add some parameters necessary for the calculation. We can input into each space all the initial data, such as values for internal temperature, information about lighting, people, electrical equipment, infiltration and any other additional cooling loads. We can also use Revit schedule to fill in parameters or input them later with Excel. Then we copy spaces with filled parameters to typical floors. After this we collect an energy model. Then we open the collected model. This is how the collected energy model looks like. Here we see only unique floors. The model is painted in different colors, which help us visually analyze the correctness of the model. We can select any element and check all the information about it. We can turn off the visibility of various elements of the model to check how correct it collects. All external surfaces should be yellow, and internal ones, green. Then, we open Tevmo plugin calculations in Revit, and now we can see automatically generated user surfaces types. We can click on any of them and all elements of that type will be highlighted on the model. Now we can see slab assembly. This is roof assembly. Then we look at the curtain wall assembly. Next, we see external wall assembly. At last, we see internal wall assembly. We create these types automatically, and it helps us be sure of the correctness of the model. We can set any U values for all these types, as well as add new. If we want to add an additional type with different parameters, then we just need to add a new row and input all the parameters. Then we select the required elements in the model. Let's click on this group of windows and assign them a new type. We can ensure that the required surfaces are assigned a new type. We see that now the selected windows no longer belong to the Windows assembly, but now they belong to the new created type. Now we can move on to the calculations. The plugin can provide 3 types of reports. Report in Excel. Export the model to a gbXML file. And the visual report. Let's start with visual report and open the model in new tab. Here we select the report model. We can see our energy model, but now surfaces with heat gains are painted in different shades of red. Color intensity depend on the amount of heat gain passing through the surface. We see that windows with a lower SHGC value are pale compared to the others. The intensity also differs for windows located on different facades. If we click on any surface, we will get access to all the information about the heat gains through that surface. Next, let's look at the report in Excel. The first table shows the calculation results for each floor. The second table contains the calculation results for each zone and space. Finally, let's see what the exported gbXML model looks like. We see that the model exports correct. With this report we can transfer all collected data to HAP or EnergyPlus, IES or Solar Computer. Thank you for watching. See you in the next video.